Another very common kind of construction is being able to copy a triangle from one place to another. So let's take a look at how that works. We're going to do the construction, and then in a later video, we're going to see how that construction is telling us some very important things about the nature of congruency. That's going to cause us to change our definition of congruency. Right now, we kind of think of two figures as congruent as being the same size and shape, which is kind of a middle school notion. But what we're going to do is we're going to come up with a more formal definition based on the kind of modern geometric practices we've been talking about so far in this class. And then we're going to be able to take it to another level beyond that. But at any rate, in this video, we're going to focus just on how to construct a triangle that has the same dimensions as the triangle we already have. All right, so here's our triangle. And so I'm going to copy the three sides of this triangle over to this side of the paper. You could be asked to do something like this, where they give you a triangle and tell you to copy it. They might also give you three line segments of a certain length. So, you know, if they said make a triangle whose line segments are this long, and this long, then what you would do is you would open up your compass to that wide and go ahead and use that as your compass line. Sorry about that. Another thing that people might do is they might say, and this is something I'm going to say to you, to make a triangle that has a side that's 4 inches long. And so if you've got your dollar store compass, you notice that there's this little gauge here. And so to get to 4 inches, you're going to get to the long side that's right next to the 4, just like that. And that's going to give you line segments that are 4 inches long between the sharp end and pencil end. There's also a centimeter on the other side. If you have a compass that doesn't have that, and you still want to measure 4 inches, you're just going to get out a ruler and you're going to put your pointing end on one end and you're going to measure 4 inches to the other end. All right, so you can do it like that. But either way, no matter what kind of compass you have, you should be able to open up your compass to a specific length. Anyway, let's take a look back at copying this. So the first thing I'm going to do is I'm going to open up my compass to be the line segment between A and B. So I want to copy that length. And what I'll do is I'll make a straight line with my straight edge. And I'm going to pick a point. And I'm going to measure off that line segment length. Just like that. All right. So this is my new line segment AB. So I'm going to call it A prime, B prime. And there's no need to keep going with this same way we've been doing it. This has A and then B, but I can reverse them. We're just going to see that there's not a whole lot of difference there. All right. Now we need to figure out where point C prime goes. So what I'm going to do is I'm going to open up my compass to be the distance between A and C. And I know that C prime is this far from A prime. So I will mark an arc. Again, the more experience you have, the smaller this arc can be. And if you figure out that you miss, you can just go back and try again. And the last thing I'm going to do is I'm going to mark the distance from B to C, because it's got to be that far from B. And you see that, lo and behold, you see that I did miss there. So no big worries. All I need to do is measure A to C again, because what I need is that intersection point. Because that intersection point is the proper distance away from A prime and the proper distance away from B prime. So that is where my C prime is going to go. And so if I take my straight edge and draw these line segments, and I have a triangle whose three sides are all the same length as the sides of the original triangle. So A prime to B prime is the same as A to B, A prime to C prime is the same as A to C, and B prime to C prime is the same as B to C. So this is a lot like the construction of the equilateral triangle, except that in this case, all of the three side lengths were not the same length.